In this video, we're going to be multiplying polynomials using 3 different strategies. We'll be using some examples from your class worksheet today, the Riddle Sheet, Why is a stick of gum like a sneeze? And the first strategy we'll be using is called FOIL. This is a very popular strategy for multiplying binomials. And in FOIL, F, O, I, L stand for things. So this is an acronym. Let's use it to multiply x plus 3 times x plus 5. Example number 1 in your class worksheet. F stands for the first 2 terms in those binomials, so x times x or x squared. O stands for the outside 2 terms. The outer terms are x times 5 or 5x. I is the inner 2 terms. 3 times x is 3x. L stands for the last 2 terms. 3 times 5 is positive 15. So now what we're going to do is write our product in standard form. This will be a quadratic expression. The 2 linear terms can be combined to get 8x. So my final answer for x plus 3 times x plus 5 is x squared plus 8x plus 15. A lot of students like FOIL because it gives them a nice, systematic, orderly way of showing their work for the product of 2 binomials. So we'll give you one for you to try. This will be example number 2 on your sheet. Write down F, O, I, and L. Show your work, combine your like terms, and write your answer in standard form. Put the video on pause. And then when you're ready, check against my answer key. Final answer, because we're going to combine our linear terms, will be x squared plus 11x plus 18. Now let's move on to another strategy called the double distributive. This is useful for multiplying a binomial by any polynomial. And we'll use this method for number 7. 4a minus 7 will be our binomial that we're multiplying by the polynomial 3a minus 2. The way double distributive works, it takes what you already know about the distributive property, but it applies it twice. So we're going to multiply 4a times 3a, and then 4a times negative 2. Then we multiply negative 7 times 3a and negative 7 times negative 2. And I'm going to color code my work. So let's look at the blue arrows. 4a times 3a is 12a squared. 4a times negative 2 is negative 8a. Now the green arrows, negative 7 times 3a is negative 21a. And negative 7 times negative 2 is positive 14. So my answer here will also be a trinomial, which is a quadratic trinomial because it's to the 2nd degree. And the 2 linear terms can be combined. So in standard form, the product is 12a squared minus 29a plus 14. Double distributive is a great strategy for using what you already understand about the distributive property, but multiplying polynomials with it. It's useful for multiplying a binomial times any other polynomial. So for number 13, let me just show you with arrows what I would do to apply the double distributive. I would distribute the first term, the n, 3 times over, and write that down. And then I would take the second term of the binomial, the positive 2, multiply it into the polynomial 3 times over. I would then combine like terms and write my final answer. Put the video on pause. Give it a try. Come back and check if we agree. So from the n times the polynomial, I get n cubed plus 5n squared minus 3n. And then when I multiply the 2 3 times over, I get plus 2n squared plus 10n minus 6. I'm going to combine my like terms. My final answer will be a cubic polynomial with 4 terms, n cubed plus 7n squared plus 7n minus 6. Right, the last strategy is often a crowd favorite, the box strategy. And we're going to use this for multiplying any polynomials. We'll start with a binomial times a binomial. And because I am multiplying 2 terms by 2 terms, I'm going to make a box, a 2 by 2 box. I'm going to write the polynomials above and to the side of the box. So 2a plus 5 goes up there, 2a minus 5 goes down there. And just like in elementary school, you may have learned about the lattice method for multiplying whole numbers, we're going to do something similar. What goes in the first top left cell is 2a times 2a, that's 4a squared. Next to that will be 2a times positive 5, or positive 10a. Underneath, negative 5 times 2a is negative 10a. Negative 5 times positive 5 is negative 25. And here the terms along the diagonal are like terms, but they are additive inverses, so they will cancel. My final product is 4a squared minus 25. So the box strategy is nice. It's useful for multiplying polynomials of any size. You will use this even into calculus, believe it or not. So I'm going to take my trinomial times a binomial, so I've made a 3 by 2 box. And along the side, I'm going to do 3n minus 1. And along the top, 2n squared plus 4n plus 2. So now I'm going to multiply and put the products in the respective cells. 3n times 2n squared is 6n cubed. 3n times 4n is 12n squared. 3n times positive 2 is positive 6n. It's better to keep the signs with the terms even if those signs are positive. Negative 1 times 2n squared is negative 2n squared. Negative 4n is the next product, and negative 2 is the last product. Are there any like terms inside the box? Well, there are quadratic terms, right, n squared terms, and there are linear terms, n terms. So let's combine those like terms and write our answer in standard form. My answer will be a cubic, 6n cubed plus 10n squared plus 2n minus 2. So that's a review of 3 strategies for multiplying polynomials.